naming and writing formulas for binary ionic compounds where metallic ions are from transition metals. So last time we learned when there were no transition metals. This time we are working on the binary ionic compounds with the transition metals. Now our job is to find out that what charge is being used when we are using transition metals, when there are transition metals in those ionic compounds. So this one, group 1, group 2, and all these groups here on the right side, they have fixed charges. Their charges are definite. Well, here a couple exceptions, but other than that, here you can see in the transition metals there are some transition metals, more than one charge, and that's the one we are using. So our job is to find out what specific charge is being used. So for instance, for here iron, we have 2 plus, 3 plus, or copper plus, 2 plus, all these charges. We're going to work on some examples. All right. So for writing names, let's start with writing names first. You want to make sure that you underline the transition metal. Okay, when you underline the transition metal, then there will be no confusion for which element you are specifying the charge. And also we use Roman numerals to show those charges, to specify the charge on transition metal. So just basic step, underline the transition metal and then use the Roman numeral to specify the type of charge on the transition metal. Let's start with the example. Iron here, FeCl2. Now we already know, you have already learned that the name of the first element remains same and the second one ends in IDE. So you already know that this is iron and this is chloride. What you have to figure out is what is the charge here on iron. We are going to use Roman numeral to specify the charge. So there are two possibilities, the charge of iron. So this one, let's underline this because this is our transition metal. For chlorine, this is fixed charge, Cl minus. So this is the one we have to figure out which one are we using for iron. Is it 2 plus or is it 3 plus? Two kinds of charges, or you can say plus 2 or plus 3, either one, it's the same thing. What you can do is, here this is iron, so we do not know the charge for iron we are using. We are going to take it as X. And chlorine here, this is these are 2 chlorine atoms and 1 iron atom. And for chloride ion, the charge is negative. You write here negative. So 2 times negative 1, we are going to get 2. Now what should be the charge? Now this is 1 atom of iron. So 1 times what will give you positive 2. 1 times X. So what should be the value of my X? It should be plus 2. Okay. Compounds have to be neutral, and that's all we are trying to figure out. How do we get the overall, the net charge on this compound? 0. So we have this charge on iron. Value of this X is plus 2 because plus 2 times 1 is plus 2. You indicate that charge by writing Roman numeral. Okay, so this is one way. Another way you can use is, so here you are going to write iron to chloride. Once again, chloride we know it is negative 1, that is fixed charge. We do not know, we are finding the charge on iron, whether it is plus 2 or it is plus 3. That is why we took it as X. And you have 1 atom of iron here, 2 atoms of chlorine. So 2 times -1, you get -2. In order to make the net charge 0 equals to 0, we have to have a +2 here. So this is 1 atom. What should be the value of X when we multiply in order to get +2, which is here +2. It has to be +2. Okay. All right. Another way you can do is, let's see if you like this way better. FeCl2. You see 2 chlorine atoms, so write 2 chlorine, and the charge on chloride ion is fixed, negative, negative. Now when you put these charges together, you're going to get -2. Here, how do I balance the charge of -2? Because remember, I want 0 in the right because compounds are neutral. So I have 1 atom of iron, so I write 1 iron. What should be the charge on iron here? Okay, since it is -2, it should be +2. Okay, so +2 cancel out and you get 0. So once again, you have charge of 2, so you write iron 2 chloride. This is another way. Okay, all right. So what else you can do is, this is called backward crisscross. You can use that. Remember, this is a compound, so compounds are neutral. Okay, but we have to figure out the charge. So this technique is called, it may not work sometimes. So backward crisscross. Crisscross, it's a backward crisscross. So iron and chlorine, you have 2 atoms of chlorine, you have 1 atom of iron. So you know that chlorine is negatively charged, that is fixed. And this has to go back. And this will give you Fe2 plus and Cl negative. So what is the charge on iron? 2 plus. So again, iron 2 chloride. So it's all up to you which technique you want to use. This is another way. Let me take another example. But very similar. FeCl3. So here, how many chlorine you remember? This is our transition metal. This has a fixed charge. Chloride ion has a fixed charge. You have 3 atoms of chlorine. So these are 3 chloride ions. Total charge -3. Now I have 1 iron here. So what should be my charge on iron in order to get total 0? It should be +3. Alright, +3. So my answer is iron 3 chloride. Okay, alright. Now the other way, once again, FeCl3, FeCl3, this is negative, but I don't know what is the charge here, but I know I have 1 iron, so I'm going to put X again here. 3 times 1, I get -3. Now what should be my value of X in order to get +3? Remember, I want 0 here because compounds are neutral. So this value has to be +3, and you get +3. Okay, specify the charge. This is iron and it is 3. Okay, now we are not even writing the formula, we are writing the name, iron 3 chloride. So this one is the name, iron 3. Specify the charge for iron. Okay. Backward crisscross. Like that, you do the backward crisscross. This is going to go here, this is here, and Fe 3 plus and Cl negative. Once again, you are going to use whichever technique you like. There is the alright. Now take another example. This example will be little different. Fe2O3. I have 3 oxygen, 1, 2, and 3. And if you look at the periodic table, this belongs to group 6, negative 2 charge on oxygen, which is fixed. 2, 2, 2. Put it together, you get negative 6. And how many atoms of iron you have? You have 1 and then 2. How am I going to get positive 6 here? Because remember, we want to cancel out these, balance these charges, protons and electrons, equal and opposite. We want to cancel them, we want to balance them. In order to have that, I should have plus 3 here and plus 3 here. That will make it plus 6. So plus 6 minus 6, and you get 0. So it is iron. Here is the charge. Iron 3 oxide. Okay. Fe2O3. Fe2O3. This one is negative 2. We do not know what is that one. So 3 times 2, 6. And here, 2 times what? What should be my value of x so that I can get here plus 6? Should be plus 3. So that will give me plus 6. 2 times plus 3. This and this cancels. So what is my charge here? What is my value of x? Value of x is plus 3. So it is iron 3 oxide. Okay, iron 3 oxide. This is my value of x. This one, and that's what goes here. This one, the x. Or again, you can do the backward. Now let's work with copper this time. Copper is also just like iron. Iron had 2 variable charges. It was 2 plus and 3 plus. With copper it is 1 plus and 2 plus. So 1 Roman numeral here, 2 Roman numeral. These are the possibilities. So our job is to figure out which one is used. Okay. Copper oxide. Can you just make a guess? What will be the charge on copper? Just take a guess. Alright. So again, once again, you know, the first element name remains same. Second one ends in IDE, copper oxide. But we need to figure out what is the charge on this one so that we can write in naming. We can mention the Roman numeral. So CuO negative 2 here. So it's because it is negative 2 and it is only 1 atom of oxygen. So here you are going to write negative 2 for oxygen. And same thing here for copper. You have only 1 atom. So what should be the charge? Plus 2. So this was straightforward. Pretty easy, right? You didn't have to do too much here. Okay, was your guess correct? Did you guess 2 or 1 in the beginning? How would you guess that this was the charge for copper was 2 plus? Well, another way, another one, Cu2O. That was the other way. You can put it this way. You have 1, 2 coppers. Here this is 2 negative charge. So what should be my charge here on copper, each copper, to get the positive 2? It should be positive 1 and positive 1. Cancel out equals 0. So it is copper 1 oxide. Okay guys? Alright. Or you can work backward. Now let's work on formula writing. So let's say cobalt to bromide. That's the example I'm taking. Bromide is fixed, which is Br, bromine, bromide, negative charge, 1 negative, it belongs to group 7. The cobalt is the one here, it's already given here, 2 plus. So formula writing is easier when we use the transition metals here. What you have to do here, look at the charges. This is 2 plus and this is 1 minus. When the charges are unequal, all you do is crisscross. And you are going to write COBr2. So that's the formula for cobalt 2 bromides. It's pretty simple. All you have to look at the Roman numeral and that is your charge for that transition metal. Let's take another example. Tin 4 oxide. So oxide is fixed, it is negative 2, but tin here it could be it could be 2 or 4, positive 2 or positive 4. So here you are given already, it is positive 4. Now since the charges are not same, when the charges are uneven, you crisscross and what do you get? SN2, and then here you're getting 4. But you have to reduce it into the simplest ratio. You divide this by 2, you divide this subscript by 2, both these subscripts when divided by 2, you get SnO2. Alright, remember, you finally reduced into the simplest ratio. Here is your answer. SnO2. Not this one. This one is the answer. Okay. Now it's your turn. Practice time. Just to check what you understood. Did you get it or not? You know, you can pause any time and then you can look at the whole explanation by pausing. So mercury 1 sulfide, manganese 4 oxide, and how about this one, CrCl2 and same type. Okay, solve this, pause the video, and if this is what you got, that means you got it. Just make sure to go back and double check the work when you're writing these formulas, the names, that the overall charge on the compound is 0. Okay, I hope you got it. You can always go back, you can always pause anytime you want to. Thank you.